Hello, welcome to Math 251, Calculus 1 here at Cañada College. My name is Lapuz and I'm the instructor for the course. In this video, we will take an overview of Chapter 2. Chapter 2 is all about limits, but we will begin the chapter with a preview of calculus. The first calculus topic we will be looking at is the tangent line problem. The idea behind the tangent line problem is to create secant lines that approach or begin to mimic the tangent line. We will use limits, and that's what this chapter is about. We will also take a look at the area under the curve problem, which will be covered at the end of this course and will also be covered in our next course. In section 2.2, we will give a working definition for a limit. A limit of a function is going to be defined so that we can find limits symbolically or algebraically, numerically, and graphically. To dig deeper into the symbolic aspects of finding limits, section 2.3 will introduce us to a lot of properties of limits, the limit laws. So properties of limits like the limit of a sum is the sum of the limits, etc. And we will dive into this other special theorem called the squeeze theorem. The squeeze theorem basically says that if you're finding the limit of a function and then you have two other functions that are bounding this function, and as you get closer to a specific point, then it actually squeezes, the two functions actually squeeze into that third function, then those limits must be the same. Related to limits are continuity issues, and the idea behind continuity is that when you're drawing your graph, as long as you don't pick up your pen, you will be drawing a continuous graph. So the interesting aspects of continuity are when things are not continuous. So we will find out when things are continuous, and when they're not continuous, we will try to identify why they are not continuous. And then finally, in our last section, we will give a formal definition for a limit. The formal definition says that if you let epsilon be bigger than 0, then you should be able to find a delta such that if you have an x value that's within delta distance of a, then your limit value will be an epsilon distance from the limit. So this idea is actually a deeper dive into the mathematics of calculus. So we will kind of browse over this, and we will attempt in doing formal proofs with some of the problems that you will have for your homework. But in general, this becomes an honors level topic. So there we have it. This is our overview for Chapter 2. Good luck.